Hi everyone, welcome to Chapter 9, which is hypothesis testing with one sample. We're going to look at a single mean and a single proportion. So just to set this up, let's talk about a typical example we might want to investigate. Suppose we wanted to test whether or not a truck actually gets 35 miles per gallon. Yeah, I just bought a Toyota Tundra used this summer. It gets about 13 miles to the gallon. Bummer. Okay, in this case, we can gather data through a random sample and perform a hypothesis test. If the results from our study are statistically improbable, given the truck gets 35 miles per gallon, we could conclude that the actual miles per gallon is in fact not 35 miles per gallon. So this is the gist of hypothesis testing. It's pretty tricky. Alrighty? Well, once you understand it, it's very not tricky at all. All right, so to perform a hypothesis test, a statistician will set up two contradictory hypotheses. They're going to collect sample data, determine the correct distribution to perform the hypothesis test, analyze that sample data by performing calculations, and then we're going to make a decision and write a meaningful conclusion. All righty. So to start it all off, we're going to do two different hypotheses. We call those the null and alternative hypotheses. So, H sub 0 is called the null hypothesis. It's a statement about the population that is either believed to be true or is used to put forth an argument, unless it can be shown to be incorrect. The alternative hypothesis, H sub A, is a claim about the population that we are looking for evidence to support, and what we conclude when we reject the null hypothesis. Okay, so this little table shows you what the null and alternative hypotheses are going to look like. The null hypothesis, H0, is always going to use equals. The alternative is going to either use does not equals, less than, or greater than. It's going to be up to you to determine which to use. Alrighty. So after we gather the data and do the analysis, we reach one of the conclusions. We reject H0, so that means there's enough evidence out there to support the alternative hypothesis, or we fail to reject H0. So there's not enough evidence to support the alternative hypothesis, all right? So those are going to be the two conclusions that we could reach in these problems. All right, the next part of it, we're going to practice setting up H0 and HA. So, a medical trial is conducted to test whether or not a new medicine reduces cholesterol by 25%. So the null hypothesis, it's a proportion problem. So the null hypothesis P equals 0.25. We want to know whether or not it reduces cholesterol by 25%. So therefore P does not equal 0.25 as the alternative. Alrighty. So say we take a sample of 200 people and we found that the mean is like 48% it reduced their cholesterol by. Chances are we're going to reject the null hypothesis in that case and assume that the alternative is true. All right? Because that would be an outlandish result given a 25% null hypothesis. All right? We want to test whether the mean height of 8th graders is 66 inches. So we got a null hypothesis, mu equals 66. And then alternative, mu does not equal 66. So it's a mean problem, so that's why you use mu for mean and not p for proportion. We want to test whether it takes fewer than 45 minutes to teach a lesson plan. So mu equals 45 is the null, and mu less than 45 would be the alternative in this case, because fewer than 45 minutes. So note that we used equal in all of the HOs, okay, H sub zeros. All right, so what distribution to use and what calculator function to use? So if we're testing for the mean with sigma known, that means if we use the normal distribution, and that's going to be the z-test, all right, on the calculator. If we know sigma, or if we don't know sigma, excuse me, you use the student's t from that fella that worked at Guinness, right? And then the calculator function in that case is t-test. And then if we're dealing with proportion, we use the normal distribution 1 prop z-test, okay? So the following requirements must be satisfied when you're doing hypothesis testing. first of all, the t-test or z-test can be used if the data comes from a simple random sample, okay, and the population is approximately normal. Or sample size is large, because then the central limit theorem comes into play, right? The sample size is large. So t-test if you have an unknown standard deviation, z-test if you know the standard deviation, okay? When testing for a single population proportion, use a normal test, one prop z-test if the data come from a simple random sample. Fill the requirements for a binomial distribution. That means you either succeed or you fail. There's no gray area, right? And then NP, number of successes, NQ, expected number of failures, are both at least 10. And then the one prop z-test will work. If those aren't at least 10, there's really not enough data. Okay? So let's talk about how to determine whether or not to reject H0. So in these problems, you're going to be given a value for alpha, the significance level. Your calculator is going to compute a p-value, which is the probability that if the random hypothesis is true, the results from another randomly selected sample will be as extreme or more extreme as the results obtained from the given sample. In other words, if we get a really small p-value, that's a really low probability that would have happened, that our data would have led to the conclusion we reached for mean or proportion, right? So very outlandish data. So that means H0 is probably not true if you get a really, really small value. So the way we do it, the conclusion we reach, if p is less than or equal to alpha, we're going to reject the null hypothesis. And if p is greater than alpha, we're going to fail to reject the null hypothesis. All right. There's going to be some problems some questions at the end of these problems that are going to be a little bit confusing. So to see how those kind of work, I would watch the chapter 9 Q&A from what I posted on the video, because that's going to go into a lot more about the conclusions you reach. Alrighty. So let's do some examples. The average salary in a town is $48,700. Is the average more for single people? So 58 randomly selected people were surveyed. I guess randomly selected single people were surveyed and had an average of $49,265 with a standard deviation of $5,200. What can be concluded at the 10% significance level? So note that we do not know sigma, so we need the t-test. So we set up the hypotheses. Mu equals 48,700 is the null. We want to know whether single people make more money. So mu greater than 48,700 is going to be the alternative hypothesis. MyOpenMath is going to ask for a test statistic in these problems. So right here, you're going to see the test statistic is this t-value. Okay, so that's the value you're going to put when they ask for test statistic. Or basically, that gives you a z-score or a t-score. So it's, where it is located on the curve, right? And then what we really are interested in figuring out is the p-value. So let's go through the steps on how to do this one. So I go to my calculator. I'm going to go stat, test, and we're going to go down to t-test. Then I got to put stats in. I don't have data in this case. I put stats in. If they give you data, put the data in. 48,700 is going to be your mu 0. Your x bar was what? 49265. So I put that in. My standard deviation was $5,200. So $5,200. My n value, the number of people surveyed, was 58. And then the biggest mistake I see students making here is they pick the incorrect does not equals less than or greater than. You look at what we did greater than right here, right? We did the greater than. So when I go back to my calculator, I just have to make sure that the greater than is selected. Enter. Then I go down to calculate, and it gives me the test statistics 0.8275 and the p-value is 0.2057. So that's the number, right? The 0.2057, that's the number you are going to compare to the confidence level to see if you're going to reject or fail to reject the null. All right, 0.2057 is definitely greater than 0.1, so we're going to fail to reject H0. Means there's insufficient evidence to suggest the mean salary is greater than $48,700. Okay, so we did not find enough evidence to reject the null hypothesis. We failed to reject it then, all right? If you fail to reject H0, look for these words in MyOpenMath, insufficient evidence, all right? If you reject it, you're going to be looking for sufficient evidence. Here we go. Let's do another one. The mean age when smokers start is 13 years old with a standard deviation of 1.8 years. A researcher thinks that due to other sources of nicotine, the mean age when smokers start is different than 13. So a survey of 34 smokers was then done. The mean starting age of this group was 12.2 years old. Do the data support the claim at a 5% level of significance? So the population standard deviation is known. It's 1.8. So ding, ding, ding. That's z-test, everybody. That's z-test. All right, so here we go. I'm going to go to z-test this time. So stat, test, down to, or right there, z-test is option number 1. We're going to use the stats again. So mu0 was 13. Sigma was what? Sigma was 1.8. X bar was 12.2. And we surveyed how many? 34 smokers. 34. And we want different than, so I use the does not equals. It becomes a two-tailed test then, right? As opposed to less than or greater than, ends up being what's called a one-tailed test. And there we go. We have our z value. That is the test statistic in this one, okay? The negative 2.59. Our p-value is 0.0096. So let's go back here. 0.0096 is the p-value. Hey, in this case, everyone, the p-value is less than the significance level of 0.05, right? 0.0096 is less than 0.05. Okay, so therefore we reject H0, meaning there is sufficient evidence to suggest the mean age when people start smoking is not equal to 13. Okay, not bad, right? That's not bad. That kind of problem. One more in this chapter. Let's do an example with population proportion. Only 10% of registered voters voted in the last election. That's pretty bad. Will voter participation change for the upcoming election? Of the 311 random voters surveyed, 25 said they will be voting. That's pretty sad. What can be concluded at the 5% level of significance? So we're going to use one prop z-test this time. Our H0 is going to be what is our given proportion. P is 0.1. They want to know if it's different, so I use P does not equal 0.1. P value and P for proportion are different, right? This P is different from that P. The first P represents proportion. This is P value. P, look at P value as the probability value. All right. So here we go. I run through one prop z-test. Let's do it. So stat, test. I go one prop z-test is item number 5. Give me my P0 is 0.1. And then I had what? My data that I collected said 25 out of 311. And I used does not equals, calculate away, and you're going to see your test statistic. It's Z, right? Because the one prop Z test is a Z test. So therefore the test stat is a Z value. So the test stat is negative 1.152 or negative 1.153. Your p-value is going to be 0.2489. Right here it gives us p hat. So this is the proportion in the sample that said they were voting is 0.08. So it's lower than the 0.1. But the p-value isn't that high, right? It's not that high. It's 0.2489. It's greater than the significance level, right? P is greater than alpha. We fail to reject H0, so there is insufficient evidence to suggest the proportion of people who vote will be different than 10%. Okay, so that is hypothesis testing in a nutshell. If we were to have a final project, it would be something like this, where you have to gather data and study it, and then choose which test you're going to use and test a hypothesis. So, if there's a final project, that's what it would be. All right, everyone. There is chapter 9. We'll see you in chapter 10. Bye-bye.